All right, so for today, I'm going to discuss about geometric sequence and series. But before that, I've noticed in your activity that there are items there wherein given the sequence, the arithmetic sequence, you are going to um, find the general rule, something like that. So how are we going to do that? So like for example, in our previous example, you still remember this. We have 3, 6, 9, 12, and 15. And then we came up with a sub n equals 3n. This is the general rule. So in your activity, given the sequence, how are you going to find this? Okay, so since this is an arithmetic sequence, we can use the general rule for arithmetic, which is a sub n equals a sub 1 plus the quantity n minus 5p. Okay, and then you just need to substitute the given, which is the first term is 3 plus the n term here is unknown because this is our goal to find the general rule given this sequence. So we'll have 7 equals the first term is 3 plus n minus 1. And given this arithmetic sequence, we know that the common difference there is 3 because 6 minus 3 is 3. 9 minus 6, 3. 12 minus 9 is still 3. 15 by 15 minus 2 is still 3. So they have common difference, which is 3. Then simplify it. So we will have 3 plus 3 multiplied by n is 3n. 3 multiplied by negative 1, the answer is negative 3. So simplify 3 minus 3 is 0. So we will have a sub n equals 3n. So if the given is an arithmetic sequence, if you are asked to find the general rule for the given sequence, you need to use, of course, the general rule for arithmetic sequence. Okay, so for today, I'm going to discuss about the geometric sequence and series. So the central question, what is a sequence and how do I find its terms and so on? So we already defined what do we mean by sequence class. Okay, it's a list of numbers with commas, right? And then how do I find its terms and so like in arithmetic, sequence, and series, we know how to get the sum of an arithmetic sequence. We can also find the unknown, okay, if it's an arithmetic. Okay, so same with geometry. So how do I find the sum in terms of geometric sequences and series? So let's define what we mean by geometric sequence. Geometric sequence class is a sequence whose consecutive terms have a common ratio. If in arithmetic sequence, an arithmetic sequence class is a sequence whose consecutive terms have a common difference. For geometric, we are talking about the common ratio. So how do we find the common ratio? Okay, given if it's a geometric sequence. So since we are talking about ratio, the operation there is division. Okay, a sequence is geometric if the ratios of consecutive terms are the same. So we'll get the ratio of the second term by the first term, which is also equal to the ratio of the third term and the second term, which is also equal to the ratio of the fourth term divided by the fourth term and the third term. So all of them are 1. So that is a common ratio, DR. Next, geometric sequence and series. A sequence is geometric if the ratios of consecutive terms are the same. So it should be applicable to the given sequence. Like this one, when we get the common ratio, this one, 8 divided by 2, so 8 divided by 2, is it equal to 32 divided by 8? So second term divided by the first term, third term divided by second, fourth term divided by the third term, and also fifth term divided by the fourth term. Are they equal? 8 divided by 2, the answer is 4. 32 divided by 8, the answer is still 4. 128 divided by 32, the answer is 4. And 512 divided by 128, the answer is 4. By the, so they have common ratio class, which is 4. So by the way, this is an example of infinite geometric sequence, since we have here ellipses. Next. So, okay, so again, we have the same answer, which is the common ratio, which is equal to 4. Next, we're going to identify if the given sequence is a geometric. Okay, and then after that, if it's a geometry, find the formula. Okay, so formula here is like the rule. What is the rule given this sequence? So let number 1, 2, 4, 8, 16, and so on. So let's find if they have common ratio. So okay, so let's do this in the board. Let's use board domain. So number 1, the given is then you're asked to find, we are going to identify if it's a geometry, then let's write the formula. So first, we need to compute for the ratio. So second term divide by the first term, third term divide by the second, fourth term divide by the third. Okay, so let's simplify. 4 divided by 2, the answer is 2. 8 divided by 4, the answer is still 2. 16 divided by 8, the answer is still 2. So they have common ratio. So it's a yes. And how about the formula? The formula plus the general rule for geometric sequence is a sub n equals a sub 1 or raised to n minus 1. Then we will just substitute the given. The first term is, and the common ratio is raised to n minus 1. Then we know this is also equal to 2 raised to 1 multiplied by 2 raised to 1 multiplied by 2 raised to n minus 1. Wherein we're going to apply one of the laws in exponents, which is the product rule, wherein it says there that when you multiply an expression with the same base, you just copy the base and add the exponent. Okay, so same here, they have same base, which is 2. So we copy the base, then add the exponent. 1 plus n minus 1. When we simplify it, so bring down n, 1 plus minus 1. So 1 minus 1 is 0. So this is now the formula. A sub n equals 2 raised to n. Next, number 2, we have letter D. 12, 36, 108, and 324. Okay, so is this a geometric? So we'll see. Let's compute for the ratio. Second term divide by the first term. Third term divide by the second term. Fourth term divide by the third term. And simplify. 36 divided by 12 is 3. 108 divided by 36, the answer is 3. 324 divided by 108, the answer is still 3. So they have common ratio, which is 3. So it's a yes. How about the formula or the rule given this geometric sequence? So we're going to apply a sub n equals a sub 1 r raised to n. Sorry, we have a sub 1 r raised to n minus 1. So substitute, the first term is 12. The common ratio is 3 raised to n minus 1. Before we apply this, we need to write 12 with the same base, which is also equal to, if one of the base is 3, 3 multiplied by 4, right? Multiplied by 3 raised to n minus 1. So copy 4 and this one, 3 raised to 1, which is also equal to 3 raised to n minus 1. So itong dalawa ay same base na. So when we simplify it, we will have 4 multiplied by 3 raised to n. Okay, so again, we will have a sub n equals 4 multiplied by 3 raised to n. That is the formula. Next, let's see. We have negative 1/3, 1/9, negative 1/7, 1/60. Is this a geometric? So let's check. GR is second term divided by the first term is equal to third term divided by the second term. Is it equal to the fourth term divided by the third term? So simplify, 1/9 divided by negative 1/3. So when we are dividing class fractions, we copy the first one, then proceed to multiplication because the inverse of division is multiplication. Then get the reciprocal of this. In finding the reciprocal, you just interchange your numerator by the denominator. Okay, then simplify it. So we can do cancellation since the operation is multiplication. So we'll have negative 3 or 9. Or when we simplify it, it's negative 1/3. Next, negative 1 over 27 proceed to multiplication, reciprocal of this, 9 over 1. So we will have negative 9 over 27, get the lowest term, which is also equal to negative 1/3. Next, 1 over 61, copy the first one, proceed to multiplication, get the reciprocal of this, negative 27 over 1. Which is, when we simplify, we can do cancellation, we'll have negative 27, 61. So when we simplify it, that's the answer. So therefore, they are not equal. So letter C, it's a no. Next, 1, 4, 9, 16. So let's check if they have common ratio. Second term divided by the first term. Third term divided by second. Fourth term divided by third term. Obviously, they're equal. So it's one. Okay. Next. It's even the n term of a geometric sequence is the form e sub n equals e sub 1 r raised to n minus 1. So this is the general rule for a geometric sequence, where r is the common ratio of consecutive terms of the sequence. So given this sequence, the first term here is 15, and the ratio is 5. Second term divided by the first term, which is 5. 375 divided by 75 is also 5. 1,875 divided by 375 is also equal to 5. So therefore, the common ratio is 5. The n term is 15 multiplied by 5n minus 1. So again, how do we get the general rule? So using again the general rule for geometric, since this is a geometric, since they have common difference, we're going to use a sub n equals a sub 1 r raised to n minus 1. The first term here is 15. The common ratio is 5 raised to n minus 1. That's why we have here 15 multiplied by 5 raised to n minus 1. Or like we did in our previous example, if we want to write 15 with the base of 5, that is also equal to 5 multiplied by 3 multiplied by 5 raised to n minus 1. So we'll have 3 multiplied by 5 raised to 1. This is also equal to this one, 3 multiplied by 5 raised to 1 multiplied by 5 raised to n minus 1. So the two factors have the same base. Therefore, you can simplify it using again the law of exponent, the power rule, x raised to m multiplied by x raised to n. So if you are multiplying expression with the same base, you just copy the base and add the exponent. So we'll copy 5 as their base and add their exponent. So we will have 10, 1 minus 1, 0. So that's it. So this is also the same with this one, 3 raised to 5 raised to n. Okay, so if you want to double check, of course, you substitute. If n is 1, so we'll have 5 raised to 1, which is 5 times 3, it's 15. If n is 2, for the second term, 5 squared, that is 25 times 3, the answer is 75. 5 cubed, that is 125 times 3, the answer is 375. Okay, same here. If n is 1, so 1 minus 1, 0. 5 raised to 0, any number raised by 0, one of the laws again, the answer is 1. 5 raised to 0, that's 1. 1 times 15, 15. If n is 2 for the second term, 2 minus 1, 1. So 5 raised to 1, it's 5 times 15, the answer is 75. So it's just the same class. Next. So finding the n-term of a geometric sequence, again, this is the general rule for geometric sequence, which is a sub n equals a sub 1 r raised to n minus 1. So where r is the ratio of the consecutive terms. So write the first 5 terms of the geometric sequence whose first term is a sub 1 equals r and r is 1/3. So let's try this example. We have the first term, which is 9, and the common ratio is 1/3. Using the general rule for geometry, a sub n equals a sub 1 or raised to n minus 1. So we already have the first term, which is 9. So let's find the second term. First term is 9. R is 1/3. Our n is 2 minus 1. Simplify, we will have 9 multiplied by 1/3. 2 minus 1 is 1. So we will have 9 multiplied by 1/3, which is 9 times 1, 9 divided by 3. 2. So the second term, so the first term is 9. Second term is 3. Next, third term, since we're asked to find the first 5 terms, so we will have the first term after fifth term. So same process, we are going to substitute the first term 9 multiplied by the r, which is 1/3. Our n now is 3 minus 1. Let's simplify. So we'll have 9 multiplied by 1/3 raised to 3 minus 1, so it's 2. And simplify again. 9 multiplied by 1 squared, that is equal to 1. 3 squared, that's equal to 9. And simplify, we will have 1. Because 9 times 1, 9 divided by 9. But this is also equal to 9 over 1. So in multiplying fraction, multiplying numerator by numerator, the denominator, 9 times 1, 9. 1 times 9, 9. 9 divided by 9, answers. So the third term is 1. Next, fourth term. So first term is 9 multiplied by the r, which is 1/3. Our n now is 4. 4 minus 1. So we will have 9 multiplied by 1/3 raised to 4 minus 1. The answer is 3. Simplify, we will have 9 multiplied by 1 cubed, that is equal to 1. 3 cubed, that is equal to 27. By the way, 3 cubed means 3 times 3 times 3. So 3 times 3, 9 times 3, 27. And simplify. 9 times 1, 9. 1 times 27, 27. Simplify. Divide both the numerator and denominator by 9. The GCF is 9. 9 divided by 9, 1. 27 divided by 9, 3. So the fourth term is 1/3. Next, the fifth term. Our n here is 5. So just follow the general rule. First term is 9 multiplied by the r, 1/3 raised to n. Our n is 5 minus 1. Simplify. We'll have 9 multiplied by 1/3 raised to 5 minus 1. The answer is 4. Simplify again. We'll have 9 1 raised to 4 is 1. 3 raised to 4 means 3 times 3 times 3 times 3. So we're going to multiply 3 4 times 3 itself. So we'll have 3 times 3, 9 times 3, 27 times 3, it's 81. So we will have 9 times 1, 9 over 81. Simplify, their GCF again is 9. 9 divide 9, 1. 81 divide 9, 9. So therefore, the fifth term is 1, 9. So this is our answer. 9, 3, 1, 1/3, and 1, 9. Okay. Example, find the 15th term of geometric sequence whose first term is A is 20. So the first term is 20. And the common ratio is 1.05. So we're asked to find here the 15th term. So given in the limits of geometric sequence, so therefore we're going to use the general for geometry, which is a sub n plus a sub 1 r raised to n minus 1. We're asked to find the 15th term, so our n there is 15. So a sub 15 equals first term is 20 multiplied by the common ratio, which is 1.05 raised to our n's in minus 1. Then simplify 20 multiplied by 1.05 raised in minus 1 becomes 14. Then get first the 14th power of 1.05, then multiply it by 20. So the answer is 39.599. That is the 15th term. Right? Okay, next example. Find the formula for the nth term, 5, 8, 45. So let's check first if it's geometric. So let's find the R. Second term divided by the first term. Third term divided by the second term. Then simplify 15 divide 5, the answer is 3. 45 divide 15, the answer is still 3. So they have common ratio. So to find the formula for the nth term, since it's a geometric, because they have common ratio, we're going to use the general rule a sub n equals a sub 1 r raised to n minus 1. So here, the first term is 5 raised multiplied by r, which is 3, raised to n minus 1. So that's it. That is the formula with the general rule. 5 multiplied by r raised to n minus 1. We cannot simplify it because they don't have the same. We cannot write 5 with a base of 3. I mean, yes, we can write because like 3 raised to 0, then, but 0 plus this is still the same, right? So no need to simplify it. What I'm trying to say, this is equal to 3 raised to 0 multiplied by 5. Because 3 raised to 0, the answer is 1 times 5 still 5. But if we add this 3 raised to 0 multiplied by 3 raised to n minus 1, yes, they have the same base. But 0 plus this is just the same, which is 3 raised to n minus 1. So this is the answer. We need to simplify. Right? So next is we're asked to find what is the ninth term. After finding the formula, we're going to find the ninth term. Okay, so same process, In our previous example, we're going to use the general rule for geometric sequence, which is a sub 1 r raised to n minus 1. Our n here is 9. Since we're asked to find the ninth term. So first term is 5. Then our r is 3. Raised to our n is 9. It's 1. Then simplify, we will have 5 multiplied by 3 raised to 9 minus 1. The answer is 8. When you simplify it, 3 raised to 8, then your answer, you're going to multiply it by 5. So the ninth term, you can double check, which is 32,805. Example number 5, the fourth term of a geometric sequence is 125. The fourth term is 125. And the 10th term is 125 over 64. Find the 14th term. Assume all terms are positive. So let's try this example using a whiteboard. Example number 5, again, the fourth term, the given of the fourth term, which is 125. The 10th term is 125 over 64. We're asked to find the 14th term and assume all terms are positive. So using the given, the first one, which is the fourth term, which is equal to 125, we know that the end there is 4. Using the general rule for geometry, we'll have a sub a plus a sub o r raised to n minus 1. Following this one, the fourth term that is equal to 125, because we don't know the value of the first term, even the ratio in our end there is 4 minus 1. Simplify, we will have 125 equals a sub 1 r 4 minus 1 is d. So we'll have 125 equals a sub 1 cube. For the 10th term, if we use that, so using the general rule again for geometry, 7 plus a sub 1 multiplied by x to n minus 1. Our n there, for a sub 10, is 10. So if n is 10, the 10th term is 125 over 64 equals a sub 1 and r are unknown, n is 10 minus 1. So we will have 125 over 64 equals a sub 1 r raised to minus 1, 9. So as we've noticed that 125, that's the fourth term, equals a sub 1 r cubed. 125 over 64 is the 10th term, equals a sub 1 is the 9. As you've noticed, when we add the sub here and the power, 1 plus 9, the answer is 10. Here, 1 plus 3, the answer is 4, which is the fourth term. So we can say that for the 10th term plus, that is also equal to fourth term times r raised to 6, because 6 plus 4, the answer is 10. So we can substitute the value of the fourth term, which is 125, for us to get the value of ratio. Okay, and we also have the value for the 10th term, which is 125 over 64. So we can find easily now the value of r. So we'll just substitute. The 10th term is 125 over 64 equals the fourth term is 125. R is unknown. It's the 6. To find the value of r, divide sides by 125. So we'll have r raised to 6 power equals. So how do we divide? Copy the first one. Proceed to multiplication. That's the inverse division. Then reciprocal of 125. 125 plus. So equal to 125 over 1. So reciprocal of that will be 125. Again, when you get the reciprocal, just interchange your numerator and denominator. Then simplify. You can do cancellation. So we will have 1 over 64 equals r raised to 6 power. To get the value of r, we need to get the 6th root on both sides. Okay, because this is the same with r raised to 6 power. 6th root, the power there is 6. So 6 times 1/6, the answer is 1. So we will have now r. And how do we get the 6th root of 1 over 64? So you think of a number that when you multiply it by itself 6 times, the answer should be equal to 1. Same with the denominator. Think of a number that when you get this, think of a number when you multiply it 6 times by itself, the answer is 64. So the 6th root of 1 is 1, because when we multiply 1 6 times by itself, the answer is 1 over the 6th root of 64. So think of a number when you multiply it 6 times by itself, the answer is 64. The answer, class, is 2, because when you multiply 2 6 times by itself, the answer is 64. So it's like 2 times 2 times 2, 8 times 2, 16 times 2, 32 times 2. So we multiply it 6 times. The answer is 60. So therefore, the value of r is 1/2. Since we already know the value of r, okay, we're asked to find the 14th term. The 14th term is also equal to the 10th term multiplied by r raised to 4, right? Because 4 plus 10, the answer is 14. And we have the value of the 10th term, which is 125 over 64 multiplied by r, which is 1 raised to 4. Then simplify 125 64 multiplied by, so the fourth power of 1 raised to 4 on 2 raised to 4, so multiply it 4 times by itself, 2 times 2, 4 times 2, 8 times 2, 16. So when we do cancellation, wala naman simplify. So let's just multiply numerator by the numerator, 125 times 125. Denominator by denominator, 64 multiplied by 16. The answer is 1024. So the 14th term is 125 over 1025. Okay, now we'll proceed to geometric series. So to find the sum of finite geometric series, so when we say finite, it means it's countable. Okay, so we have the less term for the given geometric sequence. So the formula to find the sum of a finite geometric series is S of n equals a sub 1 multiplied by 1 minus r raised to n all over
1 minus r. This is also equal to when we distribute a sub 1 in each term, a sub 1 times 1, that is a sub 1 times negative r raised to n, that is equal to a sub 1 r raised to n all over 1 minus r. So it's just the same as. If you want to use this, that's fine. Or this one, it's just the same. Okay. And then okay, find the sum of the first 12 terms of the series 4 multiplied by 0.3 raised to n. So when we get the sum of the first 12 terms, we're going to substitute our n here. For the first term, n is 1. So we just substitute 4 multiplied by 0.3 raised to 1 plus for the second term, our n is 2. So we'll have 4 multiplied by 0.3 raised to 2 plus add 2. Since we have 12 terms, our n there is 2. That is the last term. Okay. And then since it's a finite, okay, it's a finite geometric sequence, we can find. So that is the geometric series. We're going to use this formula. Again, this is just the same with a sub 1 times 1 minus r raised to n over 1 minus. Okay, so to find the sum of the first 12 terms, we're going to use this formula and just substitute the first term. When we simplify this, that is 1.2 minus the first term is 1.2 multiplied by r to find the r. Second term divided by the first term, third term divided by the second term, which is the r here is 0.3. Okay, raised to 12 because we have 12 terms. Our n there is 12 over 1 minus the common ratio is 0.3. So therefore, the sum of the first 12 terms of the given series is 1.73. Okay. Next. Find the sum of the first 5 terms of the series 5 thirds, 5, 15, up to. So this is infinite, right? We have ellipses here. So let's try to answer this example in our again. So let's go back to the first example. I'll find the sum of the first 12 terms of the series 4 multiplied by 0.3 n. So this is finite sequence because we just need to get the sum of the first 12 terms. The last term here is the 12th term, right? So this is finite. So this is just the same with 4 multiplied by 0.3 raised to 1. That's the first term. Plus 4 multiplied by 0.3 raised to 2. That's the second term. After the 12th term, which is 4 multiplied by 0.3 raised to 12. We're going to get this one. So since this, let's check first if they have common ratio. So to find the first term, let's simplify this. 4 multiplied by 0.3 raised to 1. So we will have 4 multiplied by 0.3, which is 1.2. Okay. And the second term, in the second term, we will have 4 multiplied by 0.2 raised to 2. Simplify, we will have 4 from 0.3 squared. For 0.3 multiplied by 0.3, the answer is 0.09. multiplied by 2. So we will have 0.36. Okay, so let's find the R. 0.36 divided by so that's the second term, divided by the first term, 1.2. So we will have the ratio, which is 0.3. If you want to check the third term divided by the second term plus, it's just the same, which is 0.3. Now let's continue. So since this is a finite geometric, okay, sequence, to find the sum for the geometric series, the finite geometric series, the formula again, class, is S of n equals a sub 1 multiplied by 1 minus r raised to n all over 1 minus r. So we're asked to find the sum of the first 12 terms. So our n there is 12. Okay. So first term is 1.2 multiplied by 1 minus the common ratio is 0.3, and there is raised to 12. All over 1 minus the r 0.3. Then simplify. So we can use calculator for that cycle. So you check the sum of the first 12. So let's use calculate. 1.2 multiplied by 1 minus 0.3 raised to 12. Parentheses. So you will just encode this one, calculator. Do not forget na meron tayo dito open parentheses, nandito yung close parentheses niya. Kasi ang naka-raise sa 12, ito lang sa 0.3. All over 1 minus 0.3. So the answer is 1.714 approximately. Okay, so this is approximately, because the answer, class, is irrational, 1.714. So let's use the symbol for approximate value. So we just get the approximate value. So this is the symbol for approximate, which is 1.714. Okay. Find the sum of the first 5 terms of the series 5/3, 5/15 plus. So this is infinite again, but we are just need to get the sum of the first 5 terms. Given the first 3 terms, we don't know the fourth and the fifth, but we know that we just need to get the sum up to fifth terms only. So therefore, this is a finite. It's a finite geometric, okay, series. Okay, and we know what is the last term. I mean, how many terms that we are going to add, which is only 5 terms. So it's finite. Okay, so by finding the sum of the first 5 terms, we're going to use again the formula S of n equals a sub 1 multiplied by 1 plus r raised to n. So we'll have 1 minus r raised to n all over 1 minus r. So we know that we're asked to find the first 5 terms. our n here is 5. So we'll have S of 5. The first term is 5/3 multiplied by 1 minus the R is, so 5 divided by 5/3. So again, we are dividing fractions. 5, proceed to multiplication. Copy the first one, 5, proceed to multiplication. Reciprocal of this is 3/5. So we'll have 3. Same with 15 divided 5. So they have common ratio, which is 3. 3, our n is 5. All over 1 minus 3. Then simplify, we'll have 5/3 multiplied by 1 minus 3 is to 5th power, that is equal to 243. All over 1 minus 3, it's -2. Then simplify, 5/3 multiplied by 1 minus 243, that is -242 over all over -2. So therefore our answer is positive because negative divided by negative is positive. 5/3 multiplied by -242. So 5/3 multiplied by 242 will have 403.33 divided by 2. So we will have the approximate again. So we have the sum of the first 5 terms is equal to okay. So in improper fraction, we will have 605 over 3. Okay. Para exact. Of course, if you want the approximate value of 605 divided by 3, it's 201.667. Okay? So, paano ba nakuha ang 605 over 3? So, pwedeng 5 multiplied by -242 followed by -3 times -2. Okay? So, we will have negative divided by negative. So, our answer should be positive. And then, 242 times 5. It's 1,210 divided by 3 times 2, 6. Simplify this one by 2. 1,210 divided by 2, 605. Then 6 divided by 2, the answer is 3. So we have 605 over 3, or approximately 201.667. That's it. Okay, the sum of the terms of an infinite geometric sequence is called a geometric series. So we can find now the sum for the series. Okay, for the geometric sequence, we can find the sum of the geometric sequence for infinite, even it's infinite. Okay, so the sum of the terms of an infinite geometric sequence is called a geometric series. If R is less than 1, then the infinite geometric series is a sub 1 plus a sub 1 R plus a sub 1 R squared up to has the sum. Okay, if the value of R is less than 1, this is the formula to find the infinite geometric series. A sub 1 over 1 minus 2. Okay, next. If R is greater than or equal to 1, then the series does not have a sum. Okay, we cannot find the sum if the value of R is greater than or equal to 1. So what are those numbers? R is greater than or equal to 1. So we have here from 1 up to positive infinity. So ibig sabihin lahat ng value na nasa right ni 1. Okay, which is 1.1, 1.01, 1.001, 1.2, 1.3, 1.2, 2, 3, 4. All numbers na nasa right ni 1. Okay, for this one, if that is the case, we cannot find the sum of the geometric series for the infinite geometric series. But if R is less than 1, when we say less than 1, lahat ng value na nasa left ni 1. Okay? Hindi kasama si 1. It's open to 1. R is less than 1. Ano ba yung mga nasa left ni 1? So we have 0, right? 0.5, 0.2. Negative numbers. Okay, those are less than 1. So it's from 1 up to negative infinity. So negative infinity to 1. Okay, again, we have here negative infinity to 1, but it's open. Okay, ibig sabihin, hindi kasama yung 1. Ito kasi, merong line sa ilalim. So ibig sabihin, we have bracket 1 to positive infinity. Ibig sabihin kasama si 1. 1 pataas. Dito, ang pinakamaliit na value. So we have negative numbers. Lahat ng nasa left, 1. Pero hindi kasama si 1. Okay, kasi nandito yun, oh. Kasama si 1. Pag R is equal to 1, hindi natin makuha ang sum. So ibig sabihin, yung mga nasa left ni 1. Okay, all negative numbers, okay, 0.2, 0.001, 0, that is less than 1. Next. So we have the sequence 1, 4, 7, 10, 13. So as we've noticed, this is an arithmetic sequence. They have the common difference, which is 3. Okay, and this is infinite arithmetic, right? We cannot find the sum for this one because we don't know the last one. And we know that the formula for arithmetic series is n times a sub 1 plus a sub n, which is a sub n, then a sub n there is the last all over 2, right? So we cannot find the sum for this infinite arithmetic. Next, 3, 7, 11, up to 51. So this is also an arithmetic. This is finite because we have the last term. And we know again that the formula to find the arithmetic series is this one. Okay, so it's just the same class, n multiplied by a sub 1 plus a sub n all over 2. Next, 1, 2, 4, up to 64. So this is a finite geometric, okay, because they have common ratio. 2 divided 1, 2, 4 divided 2, 2. Okay, and we have the last term, 64, so it's finite geometric. For finite geometric, we know that to find the formula for that is S sub n equals a sub 1 times 1 minus r raised to n all over 1 minus r. Next, we have this. This is infinite. So they have common ratio. 2 divided 1, 2, 4 divided 2, 2, 8 divided 4, 2. So they have common ratio. So this is infinite geometric. Okay, what is the value of r? R is 2. So it's here. r is greater than or equal to 1. If that is the case, if r is greater than 1, r is greater than or equal to 1, we cannot find the sum for the geometric series. Okay, next, 3, 1, 1/3, 1 minus 1 over 27. So we have ellipses, so it's infinite. Do they have common ratio? 1 divided by 3, so 1/3. 1/3 divided by 1, it's 1/3. 1/9 divided by 1/3, it's 1/3. 1 over 27 divided by 1/9, still 1/3. Okay, so this is infinite geometric, and the value of r is 1/3. Okay, 1/3 class is between. Hindi siya papasok dito kasi hindi naman 1/3, hindi naman greater than or equal to 1. Hindi rin siya less than sa -1, less than or equal to -1. Because itong ibig sabihin nito from negative infinity up to -1. Hindi papasok ang -1/3 dyan. So, nandito siya. It's between -1 and 1/3. Okay? Ang 1/3 ay nandito. Less than 1, right? So, if that is the case, if the value of r is between, nasa gitna, -1 and 1, the formula is a sub 1 over 1 minus r. Okay? So, let's try example. Find the sum if possible. Okay, so let's try if we can find the sum of the given geometric sequence. Find the sum if possible. 1 plus 1/2 plus 1/4 plus 1/8 up to. So this is infinite. We don't know if it's geometric, so let's find the value of r. 1/2 divided by 1. Is it the same with 1/4 divided by 1/5? Is it the same with 1/8 equals divide by 1/4? So let's simplify 1/2. So let's divide again fractions. 1/2, proceed to multiplication, reciprocal of 1, still 1/2. Next, 1/4 multiply by reciprocal of 1/2, it's 2. Is it equal to 1/8? Multiply by reciprocal of 1/4 is 4/1. So 1/2 times 1, that is 1/2. So we can do cancellation, 2 over 4. So we have 2, 1 and 2. Because 2 divided by 2, 1. 4 divided by 2. So we'll have 1 times 1, 1. 2 times 1, 2. Next, so 4 and 8. Divide by 4. 4 divided by 4, 1. 8 divided by 4, 2. So 1 times 1, 1 over 8 divided, 2 times 1, 2. So they have common ratio, which is 1/2. 1/2 class is between -1 and 1/2. So therefore, we can find the sum. Okay? So this is infinite geometric. Infinite geometric series. So the formula for that, since the value of r is between -1 and 1. So therefore, the formula is equals a sub 1 over 1 minus r. So the first term is 1 over 1 minus, the common ratio is 1/2. Simplify 1 over 1 minus 1/2, it's 1/2. So we will have divide again. So copy the first one, proceed to multiplication, reciprocal of this. So we will have the sum is 2. Okay. All right. Find the sum if possible. 2/3 plus 1/3 plus 1/6 plus 1/12 F2. So again, this is infinite. So let's check first if it's geometric. So 1/3 divided by thirds. This is equal to 1/6 divided by third. This is 1/12 divided by 6. So 1/3. The multiplication is this. This is equal to copy 1/6. This is the multiplication. This is all of this. This is equal to 1/12. This is the multiplication. This is the whole. So we will have 1/2. 3/6 simplifies to half. 6/12 simplifies. So the common ratio is 1/2. Again, our R is between -1 and 1. So therefore, we can find the sum. And the formula is a sub 1 over 1 minus R. Okay, the first term is thirds divided by 1 minus R is 1/2. Simplify thirds divided by 1 minus half is 1. So divide again fraction, dividing fractions to the plus to the multiplication. So 2 times 2 times 3. So this is the sum. 4 times. Okay. Okay, number 3. Find the sum if possible. 7 plus 4 7 plus 8 7 up to. So this is again infinite sequence. Let's find the value of R. They have common ratio. So 4/7 divided by 2/7 is 8/7 divided by 4/7. So we'll have copy the first one, this is the multiplication, this is the same with the 8/7, copy the first one, this is the multiplication, this is the simplify, so we can do cancellation. 4 divided by 2 is 2. 8 divided by 4 answer is 2. So they have common ratio which is 2. Since our R class is greater than 1, okay, we cannot find them. So next, find the sum if possible. 10 plus 5 plus 5 halves, 5 plus 5 halves plus F2. So again, this is infinite. So let's check if they have common ratio. 5 divided by 10 is it equal to 5 halves divided by 5. 5 halves, when we simplify, that is equal to 1/2 because 5 divided 5, 1, 10 divided 5, 2. This is everything. So when we simplify, that is 1/2. 5 halves, copy the first one. Set to multiplication, this is all of 5, that is 5. So we have 1/2. Okay, so 1/2, the common ratio is 1. So therefore, this is infinite geometric. The value of R again is between -1 and 1. So with that, the formula is S plus E sub 1 over 1 minus R. Okay, simplify, the first term is 10 over 1 minus R is 1/2.
So we'll have 10 over 1 minus 1 half, that is 1 half. Dividing again, fraction. So copy the first one, proceed to multiplication, reciprocal of this. So we'll have 10 times 2, it's 20. That is the sum, 20. Okay? Okay, the sum of the first 10 terms of the sequence is represented by summation notation. So like this one, again, this is sigma in summation, the summation of a sub I from 1 up to n. So you will just substitute. So the lower limit, okay, so it means that's the first, okay, you start with 1 until n. Okay, so this means that a sub 1 plus a sub 2 plus a sub 3 up to a sub n. Okay, this is the lower limit, this is the upper limit. The lower limit, where are you going to start? So you start with 1. The upper limit, the last term. Okay, so a sub n. So the summation of 4 raised to n from 1 up to 5. So you start with 1 up to 5. So you will just substitute. Will n be equal to 1 up to 5. So 4 raised to 1 plus 4 squared plus 4 cubed plus 4 to the 4th plus 4 to the 5th. Sorry, we have 4 raised to 1 plus 4 squared plus 4 cubed plus 4 to the 4th plus 4 to the 5th. When we simplify, the answer is, when we get the sum, okay, this is finite until 5th term only. So we have the sum 1,364. And we already tried this example. Yung kanina, find the sum of the first 12 terms. Here, the last term is 12 terms. So it means we have 12 terms. Like we did sa arithmetic series, ganun din dito. So write out a few terms. So this is the same with, right? You start with 1 after 12. 4 multiplied, just follow the rule. 4 multiplied by 0.3. Start with 1. Next, the second term, your n is 2. Third term, your n is 3. Up to your last term is 2. Okay. So here, when we notice, kanina, this is an example of geometric sequence. They have common ratio, which is 0.3. Our n is 12 because we have 12 terms. Okay, so we're going to get the sum of the first 12 terms. So that is finite geometric series. That this is the formula. Okay, same lang to class sa with this one. A sub 1 times 1 minus r raised to n over 1 minus r. It's just the same. Next. So when we substitute, the first term is this one, right? 4 times 0.3. Then 1 minus our r is 0.3 raised to 12 all over 1 minus 4, which is 1 minus 0.3. Same yung nakuha natin kanina. Approximately, the sum is 1.7. Okay, if the index began at I equals 0, like last topic, we started from 0, like for example, 0 to 36. So it means we have 37 terms. You would have to adjust your formula kasi mag-start ka na sa 0. Like this one. So, ibig sabihin, meron na tayong 13 terms kasi 0, 1, 2, 3, up to 12 terms. So, meron tayong 13 terms. Siyempre, may iba din sa dyan. Okay? So, which is approximately 5.714. Ang first term na natin dito ay 4.
Okay, because 0.3 raised to 0, that is 1. Any number raised by 0, the answer is 1 times 4, 4. Kaya we just need to add 4. And then we know that from this one, 1 to 12, ang summation mo ay 1.714. So we just add. So therefore, the summation of 4 multiplied by 0.3 raised to n from 0 to 12 is 5.7. Approximately 5.7. Okay, so like this one, the summation of 6 multiplied by 3/5 raised to n from 0 to infinity. So it's infinite sequence. So you start with 0, the value of n. Up to okay, infinite. So this is a infinite geometric series. Pag nakuha yung value ni r, okay, r there is less than r is between -1 and 1, which is r there is 3/5. Okay, since r is between -1 and 1, we can find the sum. So we are going to use this formula. This is for infinite geometric series, which is 15. By simplifying, the first term is 6 because this is 1, 3/5 raised to 0 is 1 times 6. So the first term is 6 over 1 minus our r is 3/5. When we simplify it, class, the sum is 15. Okay, so that's the end of the discussion. Thank you.